Welcome to the class, my dear students. This is Dr. Naga explaining you about the test of significance in different scenarios. So, in the previous couple of lectures, we have explained about the mean and the standard deviation. The population mean and the population standard deviation are known, suppose, then how to find out the Z statistic, that is for the large sample. So n greater than or equal to 30. So that is what we have done. And even for the small sample, by using the student's t-test, we have done the t calculated value when sigma is unknown. That is population standard deviation is unknown. Then in the place of population standard deviation, we will write the sample standard deviation, yes. And the square root of, then since it is a sample which is less than 30, we will be taking n minus 1. And so where S is given by the formula, this one. So these two types of formulae we have used for doing so many problems we have done in the previous lectures. Please go through those lectures. Now let us go to the next topic. What is this? That is the different scenarios where we have the two large samples. Remember, there are the two large samples. So their sample sizes are known and their sample means are known. With the population standard deviation is given, suppose, then the formula is x1 bar, that means the difference. Here what we did the sample mean and the population mean difference we have taken. Because there are two large samples, we will be taking the difference between the two large samples, and then their sample sizes are n1 and n2, and the population standard deviation is known to us, so it is sigma. Sigma times of square root of 1 over n1 plus 1 over n2. That is what the formula. Now coming to the next formula, what is that? The population, there is the two large samples, of course. Now here the population standard deviation is not known. We know only the sample. The large samples standard deviations are known to us. Their means are known to us, suppose. Then what we do? X1 bar minus x2 bar over. In the place of sigma, you have s1 square and s2 square under root. Square root of s1 square by n1 plus s2 square by n2. So this is what the test statistic. Now coming to the next one, the two test statistics for the two large populations, standard deviations are given, suppose. Then the sample, the means of the two large samples, the standard deviations of the two large samples. In the place of S1 and S2, you will be replacing S1 and N1 N2 are the sample sizes. So these are the different formulae we have to use to find out the test statistic under different scenarios. So by seeing the problem, you should understand which formula is suitable for doing the problem to find out the test of significance. So let us now solve this problem. The mean of two samples of size 1000 and 2000 are given as 67.5 and 68 inches respectively. See, the sample size is more. There are two large samples. So which is very much clear that the sample size, the first sample size is n1 is equal to 1000 and n2 is equal to 2000. And what else he has given you? He has given you the mean. What is the mean? That is x1 bar. The sample mean is x1 bar is given by 67.5. And the other sample mean x2 bar is given by 68. So this is also given to us. And what next? Can we conclude that the samples are drawn from the same population with the standard deviation 2.5 inches? So what is given here? The population standard deviation sigma is given as 2.5 inches. So by observing this data, whatever he has given, so which is the formula that is suitable for doing this type of a problem? So what is the Z calculated value is given by modulus of x1 bar minus x2 bar over sigma times of square, because we know sigma now and there are two large samples, so 1 over n1 into n2 under root. So this is what the suitable formula for finding out the Z calculated value. So let us apply this one, that is 67.5 minus 68 over 2.5 times of square root of 1 over 1000 plus 1 over 2000. So let us take the modulus of this value, and what it gives you, that gives you by doing the calculation, it is 5.163. Okay, so now in the problem this he has given, we have to see first of all, why before doing this, what is the, this is what the given conditions. Okay, now what is the claim here, we have to write that also. The claim is the null hypothesis. What is the null hypothesis? The null hypothesis is H naught is given by mu1, because there are two samples, right? With respect to the two samples, we have to find out the population means mu1 is equal to mu2, and the alternate hypothesis is given by H1 is what? Mu1 is not equal to mu2. So that is what the alternate hypothesis. He has not given you anything that less than or greater than something. So it is what? So by as soon as you see this is mu1 is not equal to mu2, it is very clear that it is two-tailed. And is there any significance, level of significance he has given you? Nothing. So when there is nothing is given as a level of significance, you take alpha as 0.05. Okay. So when you take alpha as 0.05, at 0.05 level of significance, what is the Z calculated value? And that is two-tailed. That means what? At a 95% confidence, what you have to do? Check at 95% confidence. 95% confidence. What is the Z calculated value? This, and in two-tailed. In two-tailed. This we have done in the previous lectures. I told you how to memorize these values. When two-tailed, when one-tailed, when 95% confidence, the calculated value is 1.96. So it saves some time for you, and therefore it is 1.96 is the Z calculated value. So what we have got now is Z table value it is. It is Z table value is given by 1.96, and now Z calculated value is we got it by using the table, that is Z table value, and therefore Z calculated value is how much we got? 5.163 is Z calculated value, which is greater than Z table value, and what it implies, we have to reject the null hypothesis. So reject the null hypothesis H naught. Rejecting the null hypothesis means what? Accept the alternate hypothesis, which is H1. So this is what you have to give the conclusion. I hope it is clear, all of you. So what is the null hypothesis? What is the alternate hypothesis you have to give? And what is the given data you have to write? Which is the suitable formula you have to identify? Substitute the given data values and get the solution. See the table value of at what percent of level of significance. Since it is not given, understand that it is alpha is 0.05 only, and then at a 95% confidence that Z table value is always 1.96 because it is in the two-tail, and accordingly you will give the conclusion. I hope you could understand.